We present DiffCAD, the first probabilistic approach for CAD model retrieval and alignment to an RGB image. From an image, our method reconstructs a 3D CAD-based representation of the scene, enabling a compact mesh representation broadly applicable to downstream tasks. However, such 3D perception from a single image is inherently ambiguous, for instance due to depth scale ambiguity. Additionally, occlusions in the image and lack of exact geometric matches in the CAD database induce further ambiguities. Hence, we propose to tackle this problem probabilistically. We use diffusion to model the likely distributions of scene scale, object pose, and object shape as disentangled generative tasks. We generate multiple hypotheses for different CAD model retrieval and alignment, capturing different possible depth scale ambiguity solutions. Our probabilistic approach further enables training without any real-world supervision. We first learned the distribution for likely scene scales based on a monocular depth estimate, allowing for multiple possible solutions for object translation and scale when determining the object poses. Given the scale depth map, we model object pose through diffusion to predict their knocks, or normalized object coordinates. We can then obtain the object pose from an algorithmic solver over the knocks. We use the knocks to guide diffusion for CAD retrieval in a latent shape encoding space. The latent encodings can then be used for retrieval by finding the nearest CAD encoding. At inference time, we use the predicted monocular depth and masks from real-world RGB images. We then sample progressively from our scene scale diffusion, which informs the knock estimation, which finally informs the shape retrieval. This generates multiple likely possibilities for CAD models and poses that capture inherent ambiguities in monocular CAD perception. Our approach, though trained only on synthetic data, produces more representative retrieval and alignment compared to in-domain supervised methods on real-world ScanNet data. Our probabilistic approach generates multiple hypotheses of object shape and pose. We overlay the hypotheses in 3D space corresponding to different possible scene scales on the bottom left. Here, the occluded sofa and table enable multiple possible retrievals for CAD-based reconstruction due to ambiguities in the object size. We also show robust retrieval and alignment results on ARKit data. Here, our method reliably represents various beds and cabinets despite their partial observations. Thanks for watching.